The element of the periodic table. This is the elements, a visual exploration of every known atom in the universe. I am your host, Hanchon Sean. Well, here we go. Let's start today with number 86, radon. Radon! Radon! Now, radon itself is a heavy radioactive gas with a half-life of only 3.2 days. But there is quite a lot of it because, well, the principal element in the decay chains of both uranium and thorium, well, this is basically in it. Radon itself is right there. It exists there in large quantities on the bedrock, and buildings emit significant amount of radiation. Grand Central Station in New York City is famously radioactive for this reason. Radon seeping up from the ground itself and collecting in the basements of buildings is of concern for many people, obviously, who wants radiation in their basement. A whole industry literally exists to detect and mitigate the radon. The friendly neighborhood radon abatement service will practically install expensive underground air channels and fans to draw out the radon out from underneath your house before it literally gets inside your house. Ironically though, while other people are paying big bucks to go ahead and get rid of radon, other people are paying even bigger bucks to make sure that radon is inside there. Mainly because they believe that this would be healthy. This belief, more popular 100 years ago than today, originated with the discovery that hot springs are quite radioactive. The water in them is hot because it flows near hot rocks, which are hot because of the uranium and the thorium decay deep in the earth. 100 years ago, when radioactivity was first investigated, no one had any reason to suspect it was dangerous. See, everyone knew hot springs were healthy, but no one really suspected. What no one could really say was why. When it was discovered that many hot springs are radioactive, the answer seemed obvious. It was this new radiation thingy. The result was a decades-long health fad for which all things radioactive, which ended up only the spectacular death of a lot of people. These guys were stupid because they thought that radioactivity was good for them. If only people back then knew about francium, then I'm pretty sure that people would have been selling francium foot warmers. Its density, it's 0.00973. Its atomic weight is 222. Its atomic weight is 120 picometers, and we don't even know its crystal structure, because we never really meant to measure it. Somehow, though, it's always a gas. Radon itself is always a gas. Its boiling and melting temperature are below 0. And 6p has finally been full. I really hope it stays like that, or at least 5f is full by the time we end this. But regardless, this is pretty much how we all know about it. Next up, we have francium. Francium is from, you guessed it, France. Francium is the least stable naturally occurring element, with a half-life of 22 minutes, and it is the last element to be discovered in nature, and in 1939, as you guessed it, in France. You may have heard something similar about this, that's the last thing we said about radium, that it's the last stable element discovered, but it's the last naturally occurring element discovered at the time of the writing. The last of the non-naturally occurring elements is 118. There is, however, something about francium that is a little bit off, in my opinion. Francium itself is independently radioactive. In fact, all the elements afterwards are pretty much radioactive. There are no commercial applications for it, which makes sure that there is nothing really much to talk about it. If you ever managed to even get to put a lump of it together, the thing would evaporate so violently that the tremendous heat generated by its radioactivity. But if you could somehow delay that for just a few seconds, well, look at what you could do with that. You see, francium is one of the last of the alkali metals, meaning that if you could just throw it into the lake, because they're fun to throw into lakes because they can react very, very explosively. If you could only just throw francium into the lake, wow, would that be such a fun thing to really see. Its atomic weight is 223. We don't know its density. We don't know its atomic radius because it only lasts for like 22 minutes. And its crystal structure, at least we somehow know it because we've only been able to keep one atom together for 22 minutes. And since we've never been able to get much more than one atom or 3 atoms together at the same time, we don't even know its states of matter or atomic emission spectrum. We hardly know. We don't even know if it even is a solid or liquid or a gas. We only have atoms of it together. 7s, oh come on, 7s? Well, let's just skip ahead, and we will now talk about radium. Radium is very famous for its luminous dials. Radium was the titanium of the early 1900s. It was brilliant, it was shiny, and a powerful element everyone wanted to associate their products with. Nowadays, that's titanium. At least titanium is safe. Or maybe we think it's safe now, but it might have potential health risks in the future. Just as many titanium products nowadays don't really contain lots of titanium, so did radium products a century ago, such as radium furniture polish and radium toothpaste contained almost no radium. However, some products that actually did contain radium, such as radium luminous dial watches, went ahead and kind of poisoned a lot of people. They went ahead and self-illuminated, yeah, sure, and lasted for a few days, but how it was created was kind of lethal. There were these things called the Radium Ladies, and I shouldn't say things, but they are people. There were these people named the Radium Girls, and the Radium Girls all were the ones whose job was to paint the radium paint onto the luminous watch dials, and they made sure that the needle point of the brushes were a little bit spiky, were a little thin and sharp by licking them. Yeah, licking them. And of course they ate a bunch of radium with that. No one should ever do that. No one should ever do that. Radium itself, it's not good. It's not good. Luckily, a lot of radium products doesn't really contain radium. Radium shoe polish doesn't contain radium. Radium condoms thankfully, don't contain radium. And radium starch contain no radium. And radium nocator contain large amounts of real radium and is thus among the most dangerous of the radium-average products. And there was this thing called the radium ore revigonator, which contained large amounts of highly radioactive uranium ore, but only contained a little bit of radium. Its atomic weight is 226, its density is 5, yeah, exactly 5. Its atomic radius is 215, and its crystal structure, it's a cube. It's a cube. What else would you want? 7s has been full, but now I just want these gaps to be full. Since we are at least able to see what it's like, we know its melting temperature and its boiling temperature, which are substantially low. Next up, we have actinium. We're finally splitting the periodic table again, and we're finally going back to the rare earths. This is the first of the actinides, as you've guessed it, is named after actinium. These are the ones at the very bottom row of the periodic table. The very, very bottom row. Not even, lanthanum is close, but not even close towards the very bottom. As of the lanthanide series, like all the way from lanthanum to yttrium, you go ahead and see see it all. Share chemical properties with each other, though. Lanthanides at least share chemical properties with each other. As though they are more diverse than each other, they are indistinguishable lanthanides. In fact, that's kind of one of the reasons why it took them such a long time to go ahead and get the whole mess untangled. One of the main differences between the lanthanides and the actinides is that, while the lanthanides are all stable, actinides are all radioactive. In fact, they're so radioactive that only 3 of the actinides are so stable enough that you can just hold them in your hand and live to tell the tale. Actinium, with only a half-life of 21.8 years, it's not one of those 3, though. It is so radioactive that it just glows on its own without the benefit of a fluorescent screen, which you need to see a glow from less radioactive elements, such as radium from element number 88. While actinium occurs naturally in uranium ore, there is so little of it that so many people are like, actually want some. That when people actually want some, they make it in a nuclear reactor by bombarding a bunch of uranium atoms. You can also bombard radium, I guess. They go ahead and bombard radium-226 with a bunch of neutrons to turn into radium-227, which later decays with a half-life of 42 minutes into actinium-227, the longest living isotope of actinium ever known to mankind. This kind of nuclear alchemy, literally, is the transmutation of one element into another, which is what the alchemists tried to do. It's just that they didn't have the right materials or right technology to do so. While there are some experimental applications towards actinium, though, there is nothing really worth talking about it. Its atomic weight is 227, its density is 10.070, its atomic radius is 195 picometers, its crystal structure, its cube. Well, 60 is starting to be invaded. And it has, well, I'm not sure how they even made a solid or liquid or gas version of actinium, but I'm not going to argue with the scientists. Now we're gonna have to go to the god of thunder, thorium. Thorium! There's more thorium in the Earth's crust than there is tin. Almost 3 times as much. There's almost like 3 times as much thorium there is uranium. One reason considerable work was put into research to create a viable thorium-based nuclear reactor. It was abandoned, but not before researchers stockpiled a bunch of thorium metal lusted after by element collectors. And I'm guessing that's why they're being given away. One result of thorium's abundance is that it was used for chemical purposes, used purely for its chemical properties, with complete disregard for the fact that it is radioactive, which is really stupid when you think about it. Radioactive stuff is radioactive no matter what it is. Thorium oxide was until recently used in camping mantles until they realized that they were just slowly killing campers. And you could go ahead and heat the gas, and then it too will also glow too. You can also use a solid heat of thorium metal, which is very hard to come by, well, legal to own, just to try find anyone willing to sell you one. Yeah, that's not gonna work. Antique lantern mantles usually are covered with thorium oxide, which luminesces beautifully when you heat it with gas. But then radioactive gas is much terrible than radioactive solids because you're always going to come in contact with it. And when you weld electrodes containing 2% of thorium today, they're going to go ahead, and they're still used widely today, welding electrodes still contain 2% of thorium to this day. And thoriated toothpaste is no longer made, thankfully. Its atomic weight is 232.0381. Its density is 11.724. Its atomic radius is 180 picometers. Its crystal structure, it's a cube. We have been able to make solid, liquid, and gas forms of it. Unfortunately, we do not want to make gas forms of it again. It has a really barcode-shaped version of the atomic emission spectrum. 60s keep getting invaded. And that's all I have for you guys today. For all those lovely people who like elements, I'll see you guys soon. Until next time, Shnan out. Peace. Bye-bye.